So I've titled my talk, Quantum Physics, God and Human Existence. So I ought to first give you a little bit of motivation for this talk. So some of you may know that I am a Dominican friar. Now, the Dominicans were founded in the 13th century by Saint Dominic, and he founded the order with a specific mission in mind, namely to preach the gospel for the salvation of souls. Now, before I entered Dominican life, I studied mathematics here at Cambridge, and I also went on to do a doctorate in the subject. And before entering the Dominicans, it never really occurred to me that my mathematical background would be of any relevance at all to Dominican life. But as it turned out, it is far more relevant than I anticipated. At the moment, I am actually working on a second doctorate, this time in the philosophy of physics, and I've just completed an MA in physics at Baylor University in the United States in order that I might know a little bit more about what I'm philosophizing about. And so my mathematical background has been rather helpful in all this research. Still, some of you may be wondering why on earth a Catholic priest would be interested in physics. And it really comes back to this mission of preaching the gospel for the salvation of souls. As human beings, we are beings which are both physical and spiritual. But if people don't recognize this truth and have a very distorted understanding of what we are as human beings, then this makes the Dominican mission very difficult. For instance, if people have a view of reality that precludes the existence of the human soul, then they are not going to be very receptive to the preaching of the gospel for the salvation of souls. So if we are to be effective preachers of the gospel, at least some of us preachers should have a strong enough grasp of physics to show that the truths of physics don't contradict the truths of God's revelation. Let's see if I can go down a page. Oh, okay, so now one of the big worries I had when I was a teenager and through most of my 20s was that maybe the claims of physics and the claims of revelation might contradict each other. So I thought I'd share with you a personal anecdote about these worries and how I used to deal with them. Now, I'm from a somewhat mathematical family. My eldest sister, who's 5 years older than me, also studied mathematics at Cambridge and did a PhD here. And I remember when I was about 14 years old, visiting my sister for a few days and hanging out with her mathmo friends. And I remember at one point, one of her friends asked me whether I believed in God. I said, yes, I did, to which he replied, don't worry about it. So did I when I was your age. Now, I have to admit, I did find this person rather patronizing, but I also found what he said deeply worrying. For here was a highly intelligent Cambridge undergraduate who obviously once believed in God. In fact, this person, when he was a child, was a practicing Catholic, but as he reached adulthood, he was unable to reconcile his Catholic faith with what he knew about the world. And so he decided that the only logical thing to do was to reject his Catholic faith. Now, thankfully, I didn't follow his example, but for many years, I was terrified that if I started to think seriously about my faith, I would discover that it was all a load of nonsense. So although I went to Mass frequently and said my prayers and read the Bible, I avoided any serious intellectual engagement with Catholic teaching. I was a mathematician after all, and I thought it best to restrict my intellectual engagements to mathematics and leave theologians to intellectually engage with the Catholic faith. Eventually, though, I realized I couldn't carry on like this, and I reached a crossroads. I could very nearly have lost my faith altogether, but by God's grace, I underwent a conversion. My moment of conversion was a very ordinary setting. I was on my own at home, sitting in an armchair and struggling to pray in a way that didn't feel hollow and insincere, when all of a sudden it was as though the lights were turned on. I knew I was loved by God and that he had been there beside me all along without me even realizing it. There's a saying in the first letter of St. John where he says, perfect love casts out fear. And after my conversion, this saying really struck a chord with me. The realization that I was loved by God coincided with me ceasing to be afraid to think about my faith. From that point on, I knew that if I started to think seriously about my faith, God wasn't going to abandon me. On the contrary, it seemed like it would be an exciting adventure with Christ leading the way. And so began the journey which resulted in me entering the Dominican order and being ordained to the priesthood, and more recently has resulted in me being made acting chaplain at Fisher House. So now that I'm back at Fisher House, after all these years where I was once a student, one of the things I'd really like to do is to help people who are perhaps going through the same kind of struggles I once went through, people who are maybe worried and anxious about their Catholic faith. And I want to help such people to feel more secure in their faith without this being a false sense of security. And in order to do that, we can't just pretend there are no tensions between faith and the scientific worldview. But we really need to engage with these tensions if we are to live our lives in a way that is in accord with the faith we believe. And we can engage with these intentions with a high degree of confidence if we try and live in this way. So in order to explain what I mean by that, suppose someone presents you with some argument against the Catholic faith. So we could write this as A implies B. For instance, A might be the premise that there is suffering in the world, and B might be, B might be the conclusion that God does not love us. Then there are several ways in which we might respond. So one response would be to abandon the faith. This is the option my sister's friend took. He stopped worrying about God's existence by ceasing to believe in God. And unfortunately, this is a very common response. But one way to avoid this response is to think about how you are living your life. If you are living your life in which God seems to like an irrelevance, then you will be that much more disposed to accepting arguments for God's non-existence. So I think that people who do godless and irrelevant things do so not because they have deduced that God doesn't exist, but rather they're doing godless and irreverent things makes them that much more disposed to accepting such deductions for God's non-existence. But since I obviously don't want you to abandon your faith, I'm going to cross out this response. And so that leaves us with two other possible responses. So if we were given an argument against the faith, if we consider it carefully, we might be able to show that the argument is logically flawed. This would mean that the truth of the argument's conclusion wouldn't follow from the argument's premises. And symbolically, we write this as A not implies B. And this mistake is so common, it has a name, a non sequitur, which is Latin for it does not follow. But what if the implication A implies B does seem to hold? Well, if we are convinced that B is false, it must be the case that the premise A is false. This move in philosophical debate is also very common, and it is expressed in the saying, one man's modus ponens is another man's modus tollens. So modus ponens literally means the positing way. And in this argument, you have an implication, an A implies B, and you posit the statement A and thus conclude the statement B. As for modus tollens, this literally means the taking away way. And in a modus tollens argument, you again have an implication A implies B, but this time you deny the statement B and thus conclude that statement A is to be denied. Now, an argument against the faith that I'm very interested in is one that tries to show that the question of God's existence is irrelevant to human existence. For even if you present to someone a convincing argument for God's existence, he or she might reply, so what? I don't see any relevance of God's existence in my own life. Now, I think there is a view of reality that does indeed make God's existence seem rather irrelevant to human existence. But of course, I believe that God's existence is fundamentally relevant to human existence, and that human existence is meaningful and the ultimate meaning of human existence is grounded in our relationship with God. So if there is a view of reality that seems to imply that there is no such meaning for human existence, then to me this seems like a good reason for rejecting this account of reality. So this is the one man's modus ponens is another man's modus tollens move. Now, the account of reality, which I think challenges our belief in the relevance of God to human existence, is the account of physics we typically learn in school. I'll refer to this account as classical atomism. Now, the archetypal model we tend to have in our minds when we think of classical atomism is that of a solar system. And there are some key features of the physical systems, such as solar systems, that enable us to work with them and understand them. So firstly, a physical system such as a solar system is not one thing, but many things. For instance, our solar system has a sun and 9 planets. Also, if we understand the initial states of all the individual things in the physical system, such as all their positions and velocities, we can determine all future states mathematically. In the case of our own solar system, astronomers know enough about the positions and velocities of all the planets so as to predict their future configuration up to 10 million years into the future. And these future configurations are determined purely on the basis of physical laws that can be expressed in terms of mathematics. There is no place for teleology or purpose in this determination. Nothing happens because one configuration is any better than any other configuration. All we've got to go on are the laws of physics, such as Newton's law of gravity, or since the 20th century, Einstein's general theory of relativity. Now, this understanding of physical reality is great if you want to put someone on the moon, but it becomes more problematic when we suppose that this understanding holds absolutely everywhere. And since the early 20th century, this is what physicists have tried to do. For instance, the Cambridge physicist Ernest Rutherford came up with a model of the atom after shining alpha particles at some gold foil and seeing where they were deflected. This Rutherford model of the atom is rather reminiscent of a solar system with a positively charged nucleus corresponding to the sun and then negatively charged electrons corresponding to the planets. And like a solar system, it is supposed that the behavior of an atom is governed deterministically by the particles that make up the atom, and that there is no place for teleology or purpose in this determination. Now, if gold is made up of solar system-like atoms, a natural hypothesis to entertain is the possibility that everything is made up of solar system-like atoms. This hypothesis is called atomism, and this hypothesis turns out to have great explanatory power. For instance, the physicist Richard Feynman writes in the first lecture of his lecture series in physics, if in some cataclysm all of scientific knowledge were to be destroyed and only one sentence passed on to the next generation of creatures, what statement would contain the most information in the fewest words? I believe it is the atomic hypothesis that all things are made of atoms, little particles that move around in perpetual motion, attracting each other when they are a little distance apart, but repelling upon being squeezed into one another. In that one sentence, there is an enormous amount of information about the world, if just a little bit of imagination and thinking are applied. Now, as Feynman says, the atomic hypothesis does indeed have a great amount of explanatory power. But if we take this hypothesis too literally and suppose that it gives us a complete account of reality, then it raises the question of where we as human beings fit into this account. So if atomism is true, then it implies that human beings, as well as everything else, are made of physical atoms. So we can depict this as follows. And if we zoom in to this picture, we would see that atoms make up a human being were packed tightly together, whereas the atoms in the surrounding air were more spaced out. But if that's the case, we might wonder what explanatory role this red boundary is doing, that is supposedly marking the boundary between the atoms which belong to the human being and the atoms that don't. Well, if you're an atomist, the answer is that the boundary is not doing anything at all, that it has no explanatory role to play in determining the behavior of human beings. and so we might as well deny its existence. And so we are left with a picture that looks like this. In this picture, a human being is not one thing, but rather it's an aggregate of many things. And the notion that a human being has any unity to it, or that there is such a thing as a human identity, is just a convenient fiction. All that we can, in fact, identify is lots of tiny atoms. And just like a solar system, we suppose that all future states are completely determined from previous states. So human freedom is also a convenient fiction. It's just an illusion. And just as no appeal to any purpose needs to be made to explain the motions of a solar system, likewise, no appeal to any purpose needs to be made to explain the motions of the configuration of atoms we label as human beings. If someone says they did something because they thought it was a good thing to do, this is just another convenient fiction. It wasn't the willing of something good that caused the person to move as he or she did, but rather it was the laws of physics that determined what happened. And since there is no place in this atomistic picture to entertain the hypothesis that one configuration of atoms is any better than any other, then the reasonable conclusion to draw is that human existence is without any purpose. This is a picture that has no need to posit the existence of human souls. Human existence is nothing other than the existence of atoms that happen to be in a certain configuration. Now, if someone holds this atomistic view of reality, it is rather hard to preach to them the gospel for the salvation of souls, because such a person doesn't believe he or she has a soul. So if we are going to do a one man's modus ponens is another man's modus tollens move, there must be something wrong with this atomistic view of reality. So one possible way the atomistic view of reality is mistaken could be that it is incomplete. In the atomistic picture of reality, there is no intrinsic unity to my physical existence, but nevertheless, it seems that there is an intrinsic unity to my mental existence. So we might suppose that in addition to atoms existing, there are other entities, namely minds. So it is because I have a mind that is distinct from the atoms of my body that gives me a unity to my existence. Now, this dualistic understanding of reality raises lots of philosophical questions. For instance, if it is only because I have a mind that I have any unity to my existence, then what kind of existence do I really have? Well, maybe I'm in fact just a mind, and that my body is not really a part of me. This would mean that my mind was the real me. Then there is the question of how my mind relates to my body. So perhaps there is a pre-established harmony between my mind and my body, so that the flow of thoughts in my head is in harmony with the physical movements of my body, without there being any influence of my mind on my body or vice versa. Or maybe there is some kind of interaction between my mind and my body, so that although for the most part atomic particles obey the laws of physics, perhaps sometimes they don't. For instance, when we make decisions, perhaps our minds give the atomic particles that make up our bodies little nudges, so that the particles deviate slightly from the trajectories they would follow if they were governed by purely physical laws. Now, I have to admit that before I entered the Dominicans and had studied any philosophy, I believed in this dualistic picture where minds could give particles little nudges. However, since I've decided that for a Christian, it is not a very satisfying account of reality. For instance, in the letter to the Hebrews, we're told that Jesus Christ is the Son of God, who became like us in all things but sin. But if we really are just minds and our bodies are not really a part of us, then I think this might threaten the doctrine of the incarnation. For how can we believe in the incarnation of the Son of God when we don't even believe in our own incarnation? Another difficulty this view presents is the question of why the resurrection is so important to our faith. If my mind is the real me, then I shouldn't really be too bothered if I don't have a body. Okay, I might not be able to have any effect on physical reality if there are no bodily atoms for me to move, but that doesn't really matter so long as I can have the experience of having an effect on physical reality. and that is what the pre-established harmony view says is going on. And then another difficulty is the moral implications for this view. So if my mind is the real me, this will likely alter the way I think about my body. I might be less inclined to treat my body or the bodies of other people with respect. If I see people suffering, I might decide that the merciful thing to do would be to kill them. For in killing them, I wouldn't be destroying them as persons, but I would just be severing the painful relationship between them as minds and the atomic particles of their bodies. Now, perhaps you could try showing that all these worries that might follow from this dualistic picture are just non sequiturs. However, I'm inclined to respond in another way, namely to say that the atomistic picture of reality I presented isn't just incomplete, but rather it is fundamentally flawed. And after studying a moderate amount of physics, I think we have some good reasons to think of the atomistic picture of reality as being flawed, as really just a pedagogical stepping stone. And we just need this pedagogical stepping stone because jumping straight into real physics would be much too difficult for anyone. So what are some of the reasons for calling the atomistic picture of reality into question? Well, if we go back to my previous slide, stating some of the key points of classical atomism, then we can consider how tenable these points are in the light of quantum physics. Now, one fundamental thought experiment in quantum physics is the Epr paradox, named after Einstein, Podolsky, and Rosen. In this thought experiment, you take two particles that are entangled together. It's a bit difficult to explain what entanglement means without going into the mathematical formalism of quantum physics. But if these two entangled particles are separated from one another, and both particles are sent through magnetic fields, then if the two magnetic fields are parallel to one another, the two particles will always be deflected in opposite directions. So in the diagram here, we see Bob's particle being deflected upwards and Alice's particle being deflected downwards. And Alice and Bob could be on different sides of the galaxy, but there would still be this correlation between their observations. And although the Epr paradox was first proposed as a thought experiment, this predictive behavior has been observed experimentally. But the important thing to note about the mathematical formalism of this experiment is that it's difficult to think of the two particles as separate entities. In the case of a solar system, it's easy to think of the planets as separate entities because we can describe their states independently of one another. For instance, we can describe the position and velocity of Mercury completely independently from our description of Pluto's velocity and position. But in the case of entangled particles, we can't describe them as independent entities. In the light of entanglement, it's not atomism that we should be worrying about, but rather monism. In monism, rather than positing many things to exist, only one thing is posited to exist, namely one massively complex entangled quantum wave function. When you hear popularizers of quantum physics saying that we have to fundamentally change the way we think about reality, they would typically have this monistic picture in mind. Now, I want to emphasize that I definitely don't subscribe to monism. In my doctoral research, I've been developing an interpretation of quantum theory in which there is a middle ground between the extremes of atomism and the extremes of monism, so that we can speak of medium-sized things such as a human person as being one thing. So, and another principle of quantum physics that calls into question classical atomism is the Heisenberg uncertainty principle. In classical atomism, we suppose that if we knew the exact positions and velocities of the atomic particles, we could then exactly determine their positions for all future times. However, the double slit experiment calls this assumption into question. In the double slit experiment, when we shine an electron beam through two slits, then we will get an interference pattern appearing on the detection screen, which suggests that electrons are not particles, but rather are waves. And as such, they do not have an exact position and velocity. However, if we reduce the intensity of the electron beam, we find that individual electron particles hit the detection stream. and where they are detected is not predictable with any mathematical certainty. Rather, where they appear can only be predicted probabilistically. There are still interpretations of quantum physics which are deterministic, but determinism versus non-determinism is very much an open question in the philosophy of physics. As for whether there is any place for teleology or purpose in quantum physics, I personally think there is plenty of scope for this. And an aspect of quantum physics that I think gives us a degree of maneuverability over this issue is the fact that there is currently no consensus among physicists why experiments have the outcomes they do, or why indeed experiments have any outcomes at all. This is the measurement problem. And the measurement problem raises its head most famously in the Schrodinger's cat thought experiment. In this thought experiment, a radioactive atom, which is in a superposition of its decayed and non-decayed state, gets entangled with a poison-releasing contraption. If the particle is in the decayed state, the poison is released, whereas if the particle is in the non-decayed state, the poison is not released. And if the poison is released, Schrodinger's cat dies, and if the poison is not released, Schrodinger's cat survives. According to the standard Copenhagen interpretation, the atom in superposition results in an entangled wave function with the cat being both dead and alive. And this rather bizarre physical state continues until a measurement is made, in which case the wave function collapses to a definite dead or alive state of the cat. Now, the Copenhagen interpretation of quantum physics is deeply problematic. But the point I want to make about the measurement problem is that if you consider just the mathematical formalism of quantum theory, you will never be able to describe the dynamics of something like a cat. For the dynamics of the quantum wave function are very different from the dynamics of a cat. For instance, I very much doubt that if a cat were to run into a blazing furnace, that this would entail any violation of quantum physics. But we know that running into a furnace would not be a natural kind of behavior for a cat. So with all the many possibilities that quantum physics can allow for, I think it is reasonable to suppose there are complementary principles that determine what actually happens. Following Aristotle, I believe there are forms of things like cats, and that cats act in a way so as to preserve their form. How the forms of things like cats and human beings, for that matter, fit into the formalism of quantum physics is beyond the scope of this talk. But I believe it can be done, and the result is a teleological interpretation of quantum physics. Now, I believe that being able to give an adequate answer to this question about forms is very relevant to the mission of preaching the gospel for the salvation of souls. And this is because for centuries, the Catholic Church has followed the Aristotelian definition of the soul as being the form of a living body. This Aristotelian picture is very different from the dualistic picture I painted earlier. So although we have souls and although we have minds, my soul is not my mind. My soul is rather the principle in me that actualizes what is possible for me. Although it is rather hard to draw a picture depicting this, my soul makes me to be what I am. If you were to do experiments on me using equipment that can detect particle-like interactions, you would still find I would interact in a way consistent with the predictions of quantum physics. But that doesn't entail that I am made up of atomic particles, but only that I interact with other physical systems with particle-like punches. Now I am very aware how little I've said about how we can have an understanding of human existence that is both consistent with quantum physics and with divine revelation. But if there's a take-home point from this talk, it would be the following. Our understanding of reality in the light of faith cannot contradict our understanding of reality in the light of physics. And if there appears to be a contradiction, then we should be able to resolve this in a way that does not undermine our faith. So, thank you very much for listening.